Hello, so continuing on problems from weekly contest 354, this week's contest. The third problem is minimum index of a valid split. So basically here we have an array that has a length, of course, and we have an element x that we call dominant if the frequency of x, so the number of occurrences of x multiplied by 2, is bigger than the number of the elements of the array. Okay? So basically this tells you that x occurs more than half the length of the array. That has to be the case so for it to be bigger than it's double to be bigger than the length of the array. And with this definition, that means we can only have one dominant element, right? We can only have one that verifies this condition, right? Because if you have one element that occurs more than half of the length of the array, you can't have two that have the same property, right? Because then that's more than the length of the array. So we can only have one dominant element. And we have this concept of a split where we can split at an index I such that we have to the left side 0 to I inclusive, and from the right side I plus 1 to the end. Okay? And we call this split valid only if the split, of course, is in an index of the array, but before the last element, so less than n minus 1. And both portions of the split need to have the same dominant element. Okay, so that's the constraint. And what we want is we want just the minimum index that gives us a valid split, right? And if we are not able to get one, we just return minus 1. So let's take a look at this array here. So the minimum valid split is actually this one. Then because here we get 2 occurs 2 times, 2 occurs 1 time, and both of them here, if we multiply it by 2, and then it's 4, and 4 is bigger than the length of the subarray here, which is 3, and here 2 multiplied by 1 is also bigger than 1, which is the length of the subarray. Okay, if you try other splits before this position, then here, for example, the dominant element 2 occurs just once. So 1 multiplied by 2 is 2. 2 is not bigger than 2, which is the length of the array, so that's not a valid split. And same thing with this one, just 1, because if we do take just the array with 1 as the left side, then we won't even get the same dominant element. So the first valid one is actually this one. So that's sort of the idea here. Again, the length is 10 to the power of 5. And the array's element themselves is 10 to the power of 9. So we definitely can do something that goes through the numbers, values, and we can do an over squared. So let's see how we can tackle it. Okay, so let's see how we can handle this. Well, a couple of observations. So the first one is that the problem says that we have only one dominant element, right? So let's keep this in mind. And then when you do the split, right, so we have the array, we do the split at I, so this portion becomes the left side and this portion becomes the right side, okay? Now, one observation that I'm going to make and tell you why is that the dominant element, for this to be a valid split, the dominant element in both subarray has to be the same, okay? Now, why is that the case? Well, if you have a dominant element that is not the one in the entire array, if you have a dominant element in the subarray that is not the same as the dominant element in the entire array, then that's guaranteed to be only on one of the sides. It can be on both of the sides because we are told that the dominant element means that, let's say it's x, the frequency of x multiplied by 2 is bigger than m. Okay, so if you split the array and the dominant element here is, let's say, y, then that means all of those, because the frequency of x, for this to happen, it has to be bigger than m divided by 2. Okay? Because just if you multiply, for you to get this, you have to have this. So that tells you if the dominant element is y here is another element, then that means most of the elements are here. That means we have a lot of x's. We have most of the frequency of x here. So that tells you that here the dominant element has to be x. So they won't have the same dominant element. So this won't be a valid split. Okay, so that means the observation here is that for this to be a valid split, okay, the dominant element in the left side and the right side has to be the same as the dominant element in the entire array. Okay. Now with this observation, actually we can solve the problem, because let's say, so how do we solve the problem with this? Let me take maybe let me take the simplest element, the simplest array first, which is 1, 2, 2, like this. So what we can do first is just know what is this dominant element. That's what we need to do, because once we know it, we can just search a split where this condition is valid on both split. And that's pretty much it. And so let's have some occurrence map that tells us how many times each element occurs. So 1 occurs once and 2 occurs 3 times. Okay. So once we have this, we can just go through the array. So just traverse, let me copy it. So we can just traverse the array, right? And for each index, right? So here the indices are 0, 1, 2, 3. So for each index, we can just check the occurrences of the dominant element, which is x equal to 2. We can check how many times it occurs on the left and how many times it occurs on the right, and apply this formula to the subarrays. And if it's valid for the 2 subarrays, that means we are done. We have a valid split, right? Because remember, the valid split is the 2 subarrays need to have the same dominant element. And we know that this dominant element has to be this one. So we just look for a valid split that gives us this as the dominant element for both subarrays. And so how do we do that? So first we are at position 0. We try to see if this is a valid split. So is position 0 a valid split? Well, what we can do is we of course need to know the split on the left side. So let's say left dominant count. We need to know how many times x occurs on the left side and how many times it occurs on the right side, because to do the verification that we need to do, which is the frequency of x of the dominant element multiplied by 2 needs to be bigger than this is the length. Once we have the frequency, then we can just multiply it by 2 and check against the size of the left side and the size of the right side. Now what's the size of the left side? Well, the size of the left side is, the length is just I plus 1, because remember the subarrays for the left side is going to be this one. It's 0 to I inclusive. So the length of this is I plus 1. And the size of the right side is just this minus n minus this, right? Because that's what's remaining. That's the remaining portion. So the size of the right side is going to be just n minus I plus 1, which is just n minus I minus 1. Okay. So now that we know the size, we can put it here, and the frequency, we just need to count it. So how do we count the frequency? Well, for the left, it's easy. As we go through the array, if we encounter the dominant element x, we increment it by 1. Okay, so as we encounter it, we increment it by 1. What about for the right side? Well, for the right side, it's also easy because we know the overall count of x. So we just need to subtract the overall count minus the count for the left side, and we get the count for the right side. So it's just going to be the occurrence of the x, which is the dominant element, minus the left count, which is here. Let's call it just the left count for it to be easier to write. So left count, right count. So the left count will increment as we go through the array. The right count, each time we can just get it by getting the occurrence of the dominant element minus the left count, because that's the remaining count, right? And since now we have everything, we will have everything we need, the left count, right count, and the size, we can just check if this is valid for left and right. If it is, that means this index is valid, so we return it. And why do we return it immediately? Well, because we go left to right, so we go from smallest index to the last. So the first time we encounter a valid split, we just return it. That would be the smallest index. Okay. Okay, so let's apply it. So we go here, equal to 1 is different than the dominant index 2. And so the left count is still 0. Okay, and the right count now is 3 because that's the remaining. And so this is 3, this is 0, and so we check the frequency. 0 multiplied by 2, is it bigger than the left side, which is 1 because I plus 1? No, it's not. So it's not a valid split for the left side, so we stop. And then now we go to 2. Okay, so I is equal to 1. 2 is equal to the dominant element 2, so we increment left count by 1. And so that means left count is equal to 1. What is right count? It's just 3 minus 1, so it's 2. So let's apply. So for the left side, for the right side, so for the left side is going to be 1 multiplied by 2. Is it bigger than I plus 1, which is 2? No, it's not. So it's not a valid split, so we stop here. And then we advance our pointer again. We check this one. This is equal to the dominant element for the array, so we increment left count by 2. 3 minus 2, that means that here we have only 1 left. So we apply the frequency, so it's 2 multiplied by 2. Is it bigger than the length, which is here, I is equal to 2, which is 2. So 4 is bigger than 2, so this is valid split. Now what about the right side? Right side is 1 multiplied by the length of the right side, which we said n minus I minus 1. N is 4, minus I, which is 2, minus 1 is 1. So this is this bigger than 1? Yes, so it's a valid split. So we found our first valid split, so we return the index 2. Okay. Okay, so yeah, that's pretty much the idea here. And so to get the occurrence count, here we can do just a loop, right? So that would be O of n. And then to get the dominant element, we just find the max, so it's also O of n. And then to do this pass here, we just go left to right, right? So we just do one loop left to right, so it's also O of n. So overall, it's O of n time. Now, in terms of space, we are using this occurrence map that will contain at most the number of elements, and then the rest are just values, and so this is O of n space as well. Okay. Yeah, so that's pretty much it for the overview. Let's code it up and make sure it passes. Okay, so let's code up the solution we just discussed. So first we need the occurrences of, we can get that in Python with counter for the elements of the array. And then we need to get the maximum occurrence. You could do it with a for loop, but in Python, I will do it with the easier option, which is just getting the most common element, the most common single element. And to get, so it will give us a list with just one element, like this. So it will give us the element and its number of occurrence, so the frequency of that element, like this. And for the result of that would be first in a list, so we do 0 to get that to get that first element, and then we do 0 to get the element itself. Okay, so that's sort of let's call it the dominant element. Okay, and then we have the left count for the dominant element, which initially it's 0, and we go through the array range of the length of the array, and if the number is equal to the dominant element, so x in the overview, then we want to increment this because we just found it. And then to get the count for the right side, we said we just need to get the occurrence of this element minus the left one. That will give us the remaining ones which are on the right. And then we apply our check. So we check that the count for the frequency for this dominant element on the left side, which is this here, multiplied by 2. We check that it's bigger than the size of the length of the left side, which is just I plus 1, because it's I inclusive. And for the right side, we want the frequency for the dominant element multiplied by 2 to be bigger than the length of the right side, which is n minus I plus 1. Right? So we just the remaining elements. So here we just get rid of the parentheses. That should be it. Now, if this is the case, that means this is a valid split, right? So this is a valid split. And so in this case, what do we need to do? We just need to return the index. We know it's the smallest because it's the first one we encounter in the increasing order of indices. And so we can just return it. Return I. And if we go through all the indices and we don't find a valid split, we just need to return -1. So if I run this, looks like yeah, and here is the length of the array. So let's just put n and let's create that. Okay, looks good. Let's submit. Why doesn't it? Okay, yeah, it got accepted. So yeah, it got accepted. So that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.